Okay, let's dive into this. We're going to tackle a problem that pretty much every C programmer runs into. How do you manage a ton of related data, like employee records or maybe player stats in a video game, without turning your code into an absolute mess? This is all about going from total chaos to having complete control. So imagine this. You're given a task. You've got 500 employees. For every single one, you need to keep track of their employee number, their name, and their salary. How would you even structure that in your code? Now, the first thing that comes to mind, and hey, it's how a lot of us would start out, is to just create separate arrays for everything. One giant array for all the employee numbers, another one for all the names, and a third for all the salaries. Seems logical at first glance, right? But what you end up with is like being handed this massive, messy ledger book. Picture it. The first 25 pages have only employee numbers. The next 50 pages, only names. And the last 25 have only salaries. So if you want to find all the info for, say, the very first employee, you have to look at line 1 on page 1, then flip all the way to page 26 for their name, and then flip again to page 76 for their salary. It's just chaotic. And that's exactly what the computer has to do with our code. The employee numbers are sitting in one corner of memory, the names are way over there, and the salaries are in yet another spot. To piece together just one single employee record, the computer has to jump all over the place. And as you can probably guess, that is incredibly inefficient. It's going to make our program slow. So, how do we fix this? Well, the brilliant people who created the C language knew this would be a problem. They gave us a tool, almost like a magic word that lets us get out of this mess. It lets us build our own custom data types. And that magic word is struct. So what exactly is a struct? Put simply, it's a keyword that lets you bundle a bunch of different variables, like an integer, a string of characters, and another integer, into one neat, tidy package. You get to decide what that package looks like. So let's see what this looks like in actual code. We use the keyword struct. We give our new data type a name, in this case we'll call it emp, and then, inside those curly braces, we lay out all the pieces of data that belong together. You can see how emp no, name, and sal are now all part of one single blueprint. And the result is a total game changer. We go from having our data scattered all over the place to having it perfectly organized. All the information for one employee is now grouped together just like it should be. And here's why that's so important. Because we created this blueprint, all the data for one employee, their number, name, and salary, is now sitting together in one continuous block in the computer's memory. No more jumping around. It's clean, it's efficient, and it just makes sense. So how do you actually use one? Well, it's a pretty simple 3-step process. First, you define that blueprint, just like we saw. Second, you declare a variable of that new type. Just like you'd say int I, you say struct empx. And third, you get to the individual pieces of data inside it using a simple dot. Okay, this is awesome for storing one single employee's record. But wait a minute, our original problem was managing 500 employees. How do we scale this up? The answer is actually beautifully simple. We make an array. But instead of an array of integers, we create an array of our shiny new struct type. A little line of code like struct impx for would create space for 4 complete employee records, all neatly organized one after the other. The best way to think about this is like having a perfectly organized stack of index cards. Each card is one employee, and it has all their info, number, name, salary, written right there on it. Need the next employee? Just grab the next card in the stack. It's perfectly ordered and super efficient. This is fantastic, but there's one last little challenge. See, arrays have a fixed size. What happens when you don't know ahead of time how many employees you'll have? You might need 5 today, but 500 tomorrow. Declaring a huge array just in case is a massive waste of memory. We need more flexibility. And for that, we bring out the big guns, 2 of the most powerful ideas in C, pointers and dynamic memory allocation. This combo gives us the amazing power to create exactly the amount of storage we need right when we need it. So here's how we do it. Instead of a fixed size array, we declare a pointer. Then we can actually ask the user, hey, how many records do you want to enter? Based on their answer, we use a function called malloc, which is short for memory allocation. It literally goes to the operating system and says, I need a chunk of memory just big enough for this many records. It carves out that space and hands us back the address. It's not too little, not too much, it's perfect.
Now, one tiny but super important thing to remember. When you're working with a pointer to a struct, the syntax changes just a little. Instead of using a dot to get to the members, you use an arrow, which is just a little dash followed by a greater than sign. This is how you tell the compiler, hey, I'm accessing this data through a pointer. It's a really key difference.
So let's just recap the journey we've been on. We started with the chaotic problem of scattered data. We found a basic solution with a single struct. Then we scaled it up for lots of records using arrays, and finally, we got ultimate flexibility using pointers and dynamic memory. We've literally gone from a complete mess to a really elegant, efficient solution. And that pretty much brings us to the end. You now have this incredible power to create your own custom data types in C, to group information together in a way that truly makes sense. So whether you're building that employee database, managing stats for a game, or tracking complex scientific data, the only question left is, what complex problem are you going to solve with it first?